Hello, algebra students. Welcome back. Thanks for being here. Today's Flipgrid is up there. Please check it out. They are good fun. You've already found today's YouTube lesson if you're watching this. Same thing as usual. Please pause this video and try that problem and then unpause it to do it with me. Okay, let's jump right into it. So, I noticed that there is a 2 out front here. So let me see if I can find a GCF. I see a 2. 2 times 5 is 10, and 2 times 6 is 12. But it looks like all of these have a 2 in them. So let me pull out a 2, and I'll get x squared plus 5x, because 2 times 5 is 10, plus 6, because 2 times 6 is 12. Awesome. Now if I'm going to factor even further, I am going to look at B and I'm going to look at C. Because these are both positive, they are both positive, I know that I'm going to end up with x plus something and x plus something. But I need to know what those somethings are. So I need two numbers that add to 5 and multiply together to give me 6. Let's look at the factors of 6. Let's see, we have 1 times 6 is 6. Ooh, but 1 plus 6 is 7, so that doesn't work. I think the only other factors we have are 2 times 3, which is 6, and 2 plus 3 is 5. Perfect, perfect, perfect. So this is 2 and 3. Since those are the factors, and we'll have x plus 2 and x plus 3. Fantastic. Awesome. Okay, so we pulled out the GCF right here. That's what we did. We pulled out the GCF, and then we factored it even further. So, wonderful. That's the end of that problem. Hopefully you remembered it from yesterday. Let's move on to what we have for today. Here's our learning target and success criteria for today. The learning target says, I know what polynomials in the form ax squared plus bx plus c look like. And the success criteria says, I can factor polynomials in the form of ax squared plus bx plus c. So more factoring. From here on out, it is going to be factoring in chapter 7. But today, we have a number in front of the x squared. We have an a. We had it yesterday too. You can see in our entry task we had an a there. But today, what happens when we can't pull out a greatest common factor? What happens then? So let's take a look at our first example. Factoring when AC is positive. So what I want you to notice here is that I have a number in front of the x squared. I have a 4 here. But 4 does not go into 13 or 3. So there's nothing. There's not a single thing that I can pull out of this polynomial. So, bummer. Normally, I would say let's look at things that add to 13 and multiply to give us 3. But because this 4 is here, it is not that easy. We actually can't do this. Because that 4 is there, we can't do that. So, I'm going to show you. The textbook does it in a different way. I'm going to show you the way that I like to do these problems. So what you need to do is, you need to take first the factors of 4. Let's see, there's 1 times 4, and there's 2 times 2. First, I'm going to look at 1 times 4, and then I'm going to draw a line. So over here I have my factors of 4. And on this side, on the right side here, I'm going to put my factors of 3. Now luckily there are only 2 factors of 3. There is 1 and there is 3. I'm also going to write them this way, and you will see why. Because what this is is these are kind of like, these are my x's, and these are my numbers. So in the end, I'm going to have 1x plus a number, and I'm going to have 4x plus a number. And then these numbers over here, let me use a different color. These numbers over here are what's going to tell me either a 1 goes here and a 3 goes here, or a 3 goes here and a 1 goes here. So that's what's going on here. So, get rid of all this. How we're going to decide whether a 3 goes here and a 1 goes here, the way that we are going to decide that is by, we're going to multiply across like this. And so let me do it for you and then I'll explain. 1 times 3 is 3. And 4 times 1 is 4. Is there any way that I can add 4 and 3 together to make 13? No. No, there is not. So these don't work. Those don't work. So now I'm going to do 4 times 3, which is 12. And 1 times 1, which is 1. Hey! If I add 12 and 1 together, I get 13. So, if I add 12 and I add 1 together, I get 13. So what this tells me is that I'm going to have 1x plus 3. And what this tells me is that I'm going to have 4x plus 1. Ta-da! Now, do I need the 1? Do I need right here? Right here. Do I need that 1 in front of the x? No. I don't need it. Technically, I could just do x plus 3 like that. It really doesn't matter. So there you go. That's your answer. That is your final answer for this question. So, it's a little bit more complicated than last time, which is why we have 2 examples of it. So we're going to do this one over here as well. Alright, I'm going to do the same thing. I'm going to put my factors of 3 over here, and I'm going to have my factors of 2 over here. Now my only factors of 3 are 1 and 3, and my only factors of 2 are 1 and 2. But remember, I have to write them both ways, because the 1 could go with the 1, or it could go with the 2. We don't know yet. Right, let's get a different color in here. Same thing as before. I need 1 times 2 is 2, and 3 times 1 is 3. Can I add 3 and 2 together to get me -7? Let's see, even if I had -3 and -2, that still only gives me -5, so that's not going to work. But if I do 3 times 2 is 6, and 1 times 1 is 1, hey, okay. If I take -6 and I take -1, that will give me -7. So what this tells me is that I have 1x minus 2, and remember I don't need the 1 in front of the x there, times 3x. Oh, that is hard to read. Let's write this over here. So I have 1x minus 2 and 3x minus 1. Ta-da! And we could check our answer by foiling if we really wanted to. We could foil this and see that we get 3x squared minus x minus 6x plus 2. And if you combine the like terms here, we get 3x squared minus 7x plus 2. Oh my goodness! Look at that, that's what we started with. So yes. Yes, we were right. Awesome. Awesome indeed. Let's check our answers to make sure that we were right. The x plus 3, 4x plus 1, and x minus 2, 3x minus 1. Yes, yes, we were. If you like their way of doing things better, they use a table like this. I think that takes up a lot of space, and it's a little confusing to me, the way that they pair up their numbers. And you'll see in the next example, their tables get giant, but my version of the table right here is more compact and easier for me to use and easier for me to manage. So, if you want to do their tables like this, be my guest. But I don't like it. All right, we're gonna do one more example, factoring when AC is negative. So when AC is negative, or wait, are we doing? We might have another example too. I think we actually have another example too. Forgive me. It's not the last one. When AC is negative, we have this is where we're gonna have our something x plus something, but we're also gonna have our something x minus something. So this is the only difference, again, is that one is going to be positive, one is going to be negative, and we need to figure out which one is positive and which one is negative. It is very similar, though, to what we did in our last example. So remember, I'm going to take the first number here, the a, and I'm going to take the factors of 2 on this side, and then I'm going to take the c. Well, we're just going to take, it is negative, but I'm just going to take the factors of 7 on this side. So remember, my factors of 2 are 1 and 2, and my factors of 7, the only factors of 7, are 1 and 7, but remember, I also need to write 7 and 1. Okay, let's get a different color in here. Now I'm going to do 1 times 7 is 7. 2 times 1 is 2. Is there any way that I can add 7 and 2 together to get 5? Well, if I do 7 plus negative 2, if I do 7 minus 2, I get positive 5. And if I take 2 minus 7, I'll get negative 5. So the 2 will need to be positive, and the 7 will need to be negative. So I will have 1x plus 1 and 2x minus 7. Ta-da! That easy. Let's check, though. We are going to check. Ooh. We are going to check by foiling. So we have x plus 1 times 2x minus 7. Let's make sure. So first is 2x times x, which is 2x squared. Outside is minus 7 times x. Inside is 2x times 1. And last is negative 7 times 1. Now if I combine my like terms here, I get 2x squared minus 5x minus 7. Look at that. Same thing. So the only difference between AC being positive and AC being negative is this right here, is that now one is positive and one is negative. And I have to figure out which one's positive and which one is negative. Yes. So you just look at your green numbers here and you say which one is positive, which one is negative, to give me what is in the middle here. Similar to what we did before, but a little bit different. Okay, let's check and make sure that we were right. Yeah, see, their tables get real big, and I don't like it. When you do the positives and the negatives, there get to be so many different combinations. But x plus 1, 2x minus 7. Yep, plus 1, 2. Beautiful. Alright, last example. This time I mean it. This is the last example. Now, what happens when a is negative? So see how this 4 right here is negative. What then? Oh, it's actually not that bad. It's really not that bad. All we have to do is we're going to take a negative 1 and we're going to factor it out. Just like the greatest common factor, we're going to factor out a negative 1. That makes this 4 positive. the -8 will become a +8, and the +5 will become a -5. Whew! This makes things so much easier, and I don't know if you know how, but what it does is it makes it so that I can just completely ignore that negative. In the end, I'm gonna have -1 something x plus something x minus something, and I can just leave that -1 out there, and I don't have to worry about it anymore. So, pulling the -1 out makes things, oh, so much nicer, so much easier. Alright. Same as usual, now we're gonna look at this 4 right here. We're gonna have factors of 4 on this side, and we'll do factors of 5 on this side. So let's see, factors of 4. There's 2 and 2, and there's 1 and 4. One of them isn't going to work, one of them is. We just have to guess. So I'm going to go ahead and I'm going to guess 1 and 4. And if we're wrong, we'll do 2 and 2. The factors of 5, the only factors of 5 are 1 and 5. So we write it 1 and 5 and 1. We write it both ways. And now we're going to do 1 times 4 is 4. 1 times 5 is 5. Is there any way I can put 4 and 5 together to give me 8? No, especially if one of them has to be positive and one of them has to be negative. So that is not going to work. That's not working. What about 4 times 5? That's 20. And 1 times 1 is 1. 20 minus 1 is 19, and 1 minus 20 is -19, so that's also not working. Okay, so we know that the 1 and 4 right here, not working. Not working. Luckily, we have other factors of 4. Our other factors of 4 are 2 and 2. And then our factors of 5 are 1 and 5, and 5 and 1. So let's try this again with the other factors of 4. 2 times 1 is 2, and 2 times 5 is 10. Aha! There it is. So now if I take, remember, I want to get -8 out of this. Or wait, oh, +8, excuse me. I want to get +8 out of this. So, if I have +10 minus 2, 10 minus 2 gives me 8. So I'm going to have 2x plus 5 and 2x minus 1 with our -1 out front like that. And there you have it. Now remember, we should check. We should always check our work when possible. So check by boiling. -1, 2x plus 5, 2x minus 1. 2x times 2x is 4x squared. Outside, -1 times 2x. Inside, 5 times 2x. And last is negative 5, -1 times 5. And now, remember, I still have that -1 out front. I don't lose it. And I'm going to combine my like terms. So 4x squared plus 8x minus 5. Hey! This already looks like exactly what we had over there. So if I put that -1 back in, I know I'm going to get -4x minus 8x plus 5. Which is exactly what I started with. Awesome! Awesome, awesome. So, I hope that you like this way. I hope it makes sense for you. If it doesn't, remember, always come ask me questions on my live stream. Let's check and make sure that we were right. Yep, factor out the -1. And then, yeah, see how giant? This table just gets giant, and I don't like it. But alas, -2x minus 1, 2x plus 5. There it is. 2x minus 1, 2x plus 5. Fantastic. Okay. If you had questions about anything that we did today, whether it be why we have factors of 2 over here, why we have to do both of the different factors of 3 on the right, whether it be that, whether it be what is my favorite color, although you know that by now. Any questions that you have, please come stop by my live stream from 12 to 2 p.m. Every weekday. Every weekday. Okay, homework. These are where A is positive, and these are where A is negative. Examples 2 and 3 and example 4, just like that, for your homework. I know it looks like a lot, but remember, the more practice you get with this, the better it feels. Okay, and last thing I have for you is your lunch for today. It comes to you from Demi Lovato. You probably know who she is. What she is most famous for in my heart is her Disney Channel movie Camp Rock. If you have never seen it, what are you doing? You need to go see it now, because it's fantastic. Okay, but the launch. The launch for today. No matter what you're going through, there is a light at the end of the tunnel. It might not feel like it all the time. I have been there where it just doesn't feel like there's any hope for the situation, or it will never get better, but I promise you that it will. Whatever you're going through that is super duper awful will end. And if the more you believe that, the more peace you can feel during a crazy, crazy time like that of this will end, will be over. The more you can believe that and tell yourself that, the better your noggin's gonna be, and the better life will be. Better attitude you'll have towards life. So, no matter what you're going through, there's a light at the end of the tunnel. You will get through it. Believe that, because I want you to be good in the head and in the heart. So, take that with you as you go throughout your day. Take that with you. I hope you have a wonderful rest of your day. And thanks for tuning in. Thanks for watching. Bye.